Hello and welcome to AWS Purpose-Built Databases, the right tool for the right job. My name is Thiago Volabella and I'm a Principal Technical Account Manager. Today, I would like to talk to you about how the database market is changing and how the AWS Purpose-Built Databases can help you to innovate more quickly and operate more cost-effectively. We all know that choosing the right tool for the right job can make things faster and easier. So today we are going to talk about why this is also true for databases and give you an overview of some AWS database services. Data is a strategic asset for every organization. As data continues to exponentially grow, databases are becoming increasingly crucial to understand data and convert it into valuable insights. IT leaders need to look for ways to get more value from their data. If you're running legacy databases on premises, you're likely finding that provisioning, operating, scaling, and managing databases is tedious, time-consuming, and expensive. You need modernized database solutions that allow you to spend time innovating and building new applications, not managing infrastructure. So let's first talk about three major trends that impact the way you think about data. There are three trends. One, there is an explosion of relevant data you could track. You have to track a lot of data that comes from your business applications. However, the growth is coming from data generated by network-connected smart devices that drive a variety and volume of data. Every smart device produces real-time data such as mobile phones, connected cars, wearable technologies, home appliances, security systems, industrial equipment, machinery, and electronics. Applications also generate real-time data, such as purchase data from e-commerce websites, user behavior from mobile apps, and tweets or posts from social media. So you need to be able to partner with someone who can easily harness this volume of data. 2. Microservices changes data and analytics requirements. Microservices let organizations break down a complex problem into independent units so developers can operate in small groups with less coordination and therefore respond more quickly and go faster. However, there are two implications here. First, it means developers can break down apps into smaller pieces and pick the best tool to solve each problem. And second, it increases the need for real-time monitoring, observability, and analytics to understand what's not working between all of the different microservices faster. Also, analytics is not an after-the-fact activity. It has to be built into everything that you do. You need to know what's going on in your business in real time. And 3, the DevOps model drives a rapid rate of change. As we innovate quickly, businesses are transforming IT into the DevOps model. This model uses automated development tools to enable continuous development, deployment, and improvement of software. It emphasizes communication, collaboration, and integration between software developers and IT operations. It also produces a fast rate of change and change management. This means, as you think about data and designing your data platform, you need to think about the rapid rate of change that occurs through the DevOps model. Seldom, one database fit the needs of multiple distinct use cases. The days of one-size-fits-all monolithic database are behind us, and developers are now building highly distributed applications using a multitude of purpose-built databases. Developers are doing what they do best, breaking complex applications into smaller pieces and picking the best tool to solve each problem. Instead of using the same tech for every use case, They are working backwards from the use case to the best database option. They don't want to trade off performance, reliability, or scale. If you look beneath one of these modern applications, you are not going to see a platform or database behind it. You will see most of the customers using a variety of purpose-built databases because they don't want to make sacrifices for performance, reliability, or scale. The best tool for a job usually differs by use case. So, why consider a purpose-built database? For decades, the only database choice was a relational database. So no matter the shape or function of the data in the application, the data was modeled as relational. Instead of the use case driving the requirements for the database, it was the other way around. The database was driving the data model for application use case. Is a relational database purpose-built for normalized schema and to enforce referential integrity in the database? Absolutely. But the key point here is that not all application data models or use cases match the relational model. Developers are building highly distributed and decoupled applications, and AWS enables them to build these cloud-native applications by using multiple AWS services at a fraction of the cost. First of all, instead of looking at a list of 100 different databases, what if we instead think about common database categories? This is a simple mental model to help us. By picking the best database to solve a specific problem, customers can break away from restrictive, one-size-fits-all databases and focus on building applications to meet the needs of their business. At Amazon, we are customer-obsessed. We work backwards from the needs of our customers. This means meeting the requirements of multiple distinct use cases and the scale and the speed of our customers operate. When deploying applications in the cloud, we believe that you should choose the best database for the workload, rather than to expect one monolithic database to do it all. So here you can see there is a good old relational as the first one. Then we've got key value, document, in-memory, graph, time series, ledger, and wide column. So now let's look at these database types and their use cases. A relational database is a collection of data items with predefined relationships between them. These items are organized as a set of tables with columns and rows. Tables are used to hold information about the objects to be represented in the database. Each column in a table holds a certain kind of data, and the field stores the actual value of an attribute. The rows in the table represent a collection of related values of one object or entity. This data can be accessed in many different ways without reorganizing the database tables themselves. Amazon Aurora is a MySQL and Postgres compatible relational database platform built for the cloud, with the performance and availability of commercial databases at 1/10 of the cost, delivered as a managed service. AWS decided to build Amazon Aurora using a cloud-native architecture that separates compute and storage. The storage layer has been broken out into a separate database optimized storage service that receives changes in the form of the log entries, not file system blocks. This is a huge difference and a key benefit for the Aurora platform. The storage is located across 6 locations in 3 availability zones and kept consistent by the storage service, providing a highly resilient storage tier. Backups are continuously taken from the storage service and integrated with Amazon S3 with 11 nines of durability. From a performance and scalability perspective, you are able to actually get up to 5 times more throughput for Aurora MySQL and up to 3 times with Aurora Postgres. It should be noted this is not a single query running, but lots of connections running lots of queries. If you would like to know more, AWS has published the benchmark information and how to replicate the benchmarks on the AWS website. RDS, or Relational Database Service, giving its name, it's focused on relational databases, and it offers a fully managed service for MySQL, Postgres, MariaDB, Microsoft SQL Service, and Oracle databases. A key-value database is a type of non-relational database that uses a simple key-value method to store data. A key-value database stores data as a collection of key-value pairs in which keys serves as a unique identifier. Both keys and values can be anything, ranging from simple objects to complex compound objects. Key-value databases are highly partitionable and allow horizontal scale at scales that other types of databases cannot achieve. They are great for applications that need instant scale to meet growing or unpredictable workloads. Amazon DynamoDB is a key-value database that delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, high-available, multi-writer, durable database with built-in security backup and restore, and in-memory caching for internet-scale applications. Many of the world's fastest-growing businesses, such as Lyft, Airbnb, and Redfin, as well as enterprises such as Samsung, Toyota, and Capital One, depend on the scale and performance of DynamoDB to support their mission-critical workloads. Also, many of our services depend on DynamoDB to make sure that they are running themselves. So you can trust this is a super reliable database. You can start with a very minimal throughput requirement, and then as your application becomes successful, you can increase that throughput. Or we have the auto-scaling capability where you can actually have DynamoDB provision extra throughput automatically, depending on the requests that are coming through. It's a serverless architecture, so you don't have to worry about managing servers or EC2 instances. The DynamoDB service has been around 2012, so if you haven't looked at it a while ago, you might not be aware of some of the new features added over the last year or so. So we now have on-demand capacity mode. We offer built-in support for ACID transactions. You can provision on-demand backups and point-in-time recovery, and we now support encryption at rest. Let's take a look at some of our customers that are using multiple different kinds of databases to build applications. An online provider of free language training with a global audience of 300 million, Duolingo relies on AWS to store and serve up to over 31 billion items for 80 different language courses. Duolingo uses Amazon DynamoDB as one of its primary database solutions. Each second, Duolingo's DynamoDB implementation supports 24,000 reads and 3,000 writes, personalizing lessons for users taking 6 billion exercises per month. Duolingo also uses Amazon Aurora as the transactional database for maintaining user data. With this database backbone, Duolingo teaches more language students than the entire US school system. So let's talk about document databases. Why document databases? Customers use document databases when they want maximum flexibility on how data is organized and queried. So an example use case are applications for content management, personalization, or mobile app. In the personalization scenario, instead of creating a user table with a strict schema where every entry adheres to, imagine every user being individual model on a document. Document databases make it easier for developers to store and query data by using the same document model format developers use in their applications. Amazon Document DB is a fast, scalable, fully managed and MongoDB-compatible AWS document database service. If you are managing MongoDB on EC2 or on-premises and are troubled with that undifferentiated heavy lifting of those systems, and if you are looking for that fully managed solution, Amazon Document DB is a great choice. So essentially what we are doing here is giving your application a response that it would expect from a MongoDB database. Now that means that your applications today, you can simply take them from pointing at a MongoDB and point them to Amazon Document DB, and they will continue to work as they were previously. So it's a great flexibility to bring this into a managed service on AWS, as well as if you used MongoDB and try to scale it up, and then perhaps even scale it back down, you know that process is quite trying. Now with Amazon Document DB, we can actually spin up read replicas up to 15 very simply, and then when you don't need them, you can actually turn them off. So you're going to be able to get a much better service for you to scale up and down with Amazon Document DB than if you are running MongoDB yourself. And I think this is something that is a really big pain point for many of MongoDB customers that I've talked to. So I would highly recommend you to start looking at Amazon Document DB if you have a MongoDB database. Another customer example is Finra. Finra chose Amazon Document DB because it natively stores data in JSON, make it simpler to query and index regulatory documents. This reduces their development cycles while extending the usability of their data by easily integrating with other systems that leverage JSON. So the next one we are going to talk about is in-memory databases. With the rise of real-time applications, in-memory databases are growing in popularity. In-memory databases predominantly rely on main memory for data storage, management, and manipulation. In-memory databases are designed to attain minimal response time by eliminating the need to access disks and are ideal for applications that require microsecond response times. Memcache and Redis are the two caching solutions offered by the Elastic Cache service. Let's take a look at each engine. So Memcache is pretty much a straightforward cache where you store strings. You put the data in, you get it out. It does allow you to actually scale across a number of different nodes, but fundamentally it's a pure cache. Whereas Redis is more an in-memory database. And what we are seeing in that most customers are adopting Redis these days, and some of the capabilities that it has include atomic operations, which are really important for things like counters to make sure that you're getting the actual increments that you want, and then PubSub, which is quite complex and well implemented to allow people to use things like queues. And then there is ordered sets. Now, ordered sets are great for things like leaderboards. So if you got a game and if you want to see your top scores, then that could be already ordered in memory from the Redis database and just pulled out and displayed in your application. We do also see caching being used as a kind of its own data store, especially for things like session management and even more complex use cases. But one of the other use cases we see is the protection of a relational database. That means that you can put a memory cache in front of your relational database, get a lot of reads from it, and protect the relational database, so you don't have to scale as much. This is really good because if you think of things like e-commerce websites where you've got product catalogs that it's mostly read-only, it's going to be served much faster to your customers. So not only you are protecting your relational database, but you are improving your user experience as well. Let's talk about graph databases. Graph databases are a type of NoSQL database designed to make it easy to build and run applications that work with highly connected data sets. Graph databases have advantages over relational databases for certain use cases, including social networking, recommendation engines, and fraud detection, when you want to create relationships between data and quickly query these relationships. There are a number of challenges to building these types of applications using a relational database, as it requires you to have multiple tables with multiple foreign keys, and the SQL queries to navigate this data require nested queries and complex joins that will quickly become clumsy. And the queries don't perform well as your data size grows over time. In graph databases, traversing the joins or relationships, it's very fast because the relationships between nodes are not calculated at query times but are persisted in the database. Amazon Neptune is a graph database from AWS. And again, this is a fully managed service using open source and open standards. So you've got Tinkerpop and W3C RDF as the graph models, and then the languages that you're going to be querying with are Gremlin and Sparkle. As I said, a good use case for graph databases is detecting fraud. For example, you can track credit card purchases and purchase locations to detect uncharacteristic use. Detecting fraudulent accounts is another example. With Amazon Neptune, you can use relationships to process financial and purchase transactions in near real time to easily detect fraud patterns. The graph you see on this screen shows you the relationship of 3 people and their identity-related information. Each person has an address, a bank account, and a social security number. However, we see that Matt and Justin share the same social security number, which is irregular, and indicates possible fraud by one or more of the connected people. A query to the graph database would help you to discover these types of connections so they can be reviewed later. So what I'm going to do now is to give you an actual demo of how Neptune works, show you how you can easily